Hey folks, welcome back to another video. Today we're looking at question 1110, delete nodes and return forest. The way we'll be solving this problem is by using recursion. Anytime you see like a tree problem, it's safe to assume that you'll be using recursion in some form or the other to solve the problem. So let's jump right in. You actually need two things right before you get started. You need to have a list that we'll actually store all the root nodes in. So let's just create that. And the reason why we're creating it outside the delete node method is because we want to be able to access it globally. And you also want to create a hash set. The reason why we will be creating a hash set is because, give me 1 second. The reason why we'll be creating a hash set is because anytime we want to check whether a given tree node's value exists in the to delete list or not, we have to iterate through everything. So to minimize the amount of time that we need to check whether something has to be deleted or not, we will be adding everything to the hash set. Awesome. So let's initialize this. So it'll be new hash set, sorry, and then the other one would be result will be equal to new array list. Awesome. Once you have that, all you want to do is you want to add all of the to delete values into the hash set. Let's actually just call this set just for simplicity. Wait, okay, so set.add hi. Awesome. So once that's done, we'll have a helper method right here. So the type of value to be returning is the tree node, and it'll have a helper, and you need two things. Obviously, you need the tree node to check whether the current node is to be deleted or not, and the other thing you need is like a Boolean value that keeps a track of whether the given node is a root node or not. So we'll get to that in a second, but let's just complete the delete node method. So what you'll do here, you'll just call the helper method on the root, and then it's asking for one more parameter, right? And the parameter is whether it's a root or not. But for right now, let's just pass true, and we'll understand why we need that. And then in the end, we just need to return the list. Rest. Awesome. So the reason why we need like is root Boolean is because anytime a particular node has to be deleted. So for example, in this case, it's like 3 and 5, right? So if you delete 3 right here, like 6 and 7, they become the root nodes. So you need to check whether the previous node, like the parent node, has to be deleted or not. If it was, it becomes the next nodes, like the left node and then right node, which are the children node of a given node, or they will become the root node. So that's the reason why you need the is root, and because the question asks, you need to return the roots of the forest, the remaining roots. So that's why we need to track that. So let's let's start coding the helper method. The first thing you need to check is actually if the node is equal to null, which is the base case, you would just return null. Right, and then the next thing you need to do is you need to check whether it's deleted or not. To delete, and how do you know that? You know that if the given node's value is in the set or not. So if set dot contains node dot value. Awesome. So once you have that, the next thing you need to know is that, hey, like, does this make sense? Like the given node, do we add that to the list? And how do we know that? So if it is not deleted, right? And if it is the tree node, sorry, the root node, then you add it. It's rest.add node. So what exactly are you checking? You're checking for two things. Because we only need to return the roots of the tree in the remaining forest, first you're checking whether it's a root or not. And then the other thing you're checking is whether the given node has to be deleted or not. If it is not, it doesn't have to be deleted. And if it's a root node, you will add that to the list, right? And you need to continue with the other node. So what you need to do is you need to call that on root node.left. So this would be helper node.left, and then you would say to delete. And the reason why you're passing to delete is because if a given node, like the parent node, is to be deleted, the children node become the roots. So the to delete will actually, this boolean right here gets converted to like the is root node. So if a current node is to be deleted, the next nodes, which are the left and the right nodes, become the roots. So that's the reason why you pass that value back. And you need to do the same for right. Awesome. And in the end, the return values, all you need to do is that, hey, if the given node has to be deleted, then because you know it has to be deleted, you just return null. Otherwise, you return the node. Awesome. So let's try compiling this and see if it's okay. The first test case is okay. Everything else is okay as well. Awesome. So let's talk about the space and the time complexity of the entire solution. The time complexity of the entire solution is O of n. Since you are going through all of the nodes in the tree before you return the result. And the space complexity is also O of n, since you are storing the nodes in the list that needs to be returned back. Awesome. If you have any questions about this problem, please let me know in the comments below. Don't forget to subscribe to the channel, like the video. It really motivates me to continue making more videos. So thank you so much, and I'll see you all in the next video. Peace.